Hello everyone, welcome back to my channel. It's me Abhay. Today we are going to be starting the next part of vectors. It is vector addition. This topic is very important. So without wasting any further time, let us get into this video. So what and all are we going to learn? So first we will recap what a vector is. Okay. Next, we will modify the definition of the vector. Next, we will see the difference between algebraic addition and vector addition. Okay. Next, we'll learn two types of vector addition, which is triangle law and parallelogram law, and we learn each of them in detail. And at last, we will deal with some questions. Okay. First, let us quickly recap what a vector is. Tell me, everyone, tell me what a vector is. A vector is a quantity which has both magnitude and direction. Correct? Is this what you learned? Yes, this is what you learned at that time. But is this definition always true? Is this definition always true? Let us check. Here I have written something called as current example. Oh, current, if you take electric current, okay, 3 ampere, it is moving from it's moving in this direction. Now, so it has magnitude, yes, 3 amp, and it has direction, yes, it is moving in this direction. So according to this, what should current be? Current should be a vector. But what actually current is? Actually, current is a scalar. If you want, you can check it. Current is a scalar. But how? This defies our original definition of vector. So what we are going to do is we are going to be modifying our vector definition. What are we going to be doing? We are going to modify our initial vector definition. Let us modify it. Now, so what actually is a vector? A quantity is said to be a vector if it follows the rules of vector addition, which is necessarily not equal to algebraic addition. So initially, what criteria were we looking at? We were initially looking at magnitude, direction. So if it has both, this is a vector. Now, forget about these two quantities. Forget about these two quantities. Just check if a quantity, okay, if it follows vector addition. If a quantity follows vector addition or follows the rules of vector addition, this quantity is said to be a vector. If that quantity defies the rules of vector addition, then that quantity will not be a vector. Is this clear? Okay, so I told something called as vector addition. Okay, vector addition I mentioned, will go in detail. Before going to the definition of vector addition, let us actually see the difference between vector addition and algebraic addition. First, algebraic addition is what? Simple addition. It is what? Simple mathematical addition. That is what? 1 plus 1, 2, 10 plus 5, 15. Simple. Then, like for example, assume this is the starting point, this is ending point. Now let us talk about distance. Distance what? Is a scalar that you know. Okay, we'll prove distance is a scalar here. Now, here to here, what did you do? You moved 10 meters. Then from here to here, what did you do? You moved 5 meters. Then from here to here, you moved 4 meters. Now, if they ask total distance, what will you do? We'll do as distance. Remember, I'm talking about distance, not displacement, which is nothing but of 10 plus 5 plus 4, which is 19. Here, did you consider that this is forward, this is backward, that thing? Okay. Direction doesn't matter. Is this clear? It doesn't matter if you're moving this way, or this way, this way. It doesn't matter. Direction doesn't matter in algebraic addition. What and all the numbers they are given, just add it up and give the suitable unit. Okay, that's it. So it's what simple mathematical addition that you understand. Direction doesn't matter, and algebraic addition is applicable for who? Scalars quantity. And what is a number? A number is also a scalar. How? It has only magnitude, so it is a scalar. So algebraic addition is applicable only for scalar quantity. Is this clear? Now, what about vector addition? This vector addition is not simple mathematical addition subtraction. See, what you did for algebraic addition, you simply added them or simply subtracted them, right? Here, this is not just simple mathematical addition or subtraction. There are some specific formulas which you are going to learn in the later part of the video. Okay? So it is not simple mathematical addition or subtraction. Now, here for vector addition to be performed, you always need the direction of the vector quantity. Okay? For example, let us say you have one vector quantity which is in this direction and a vector quantity which is in this direction. Okay? Now, assume you add these two vector quantities and take this as one. Now, take one more. I'll give like this and I'll give like this. Only one of the directions I'll change, and when you add these two vectors, the result in 1 and the result in 2 will always be different. So the direction for vector addition is always required. And this vector addition is applicable only for vector quantities. So this becomes our only criteria to determine whether a quantity is a vector or a scalar. Let us go to the next part. Okay, we learned what is the difference between vector addition and scalar addition. Okay, algebraic addition. Now, let us see how it solves our initial limitation, or does it solve our initial limitation? Let us check. Now, as all of you know currents, right? Now, take this wire. Assume there are three wires which are connected, A, B, C. Now, assume here you are having 3 ampere of current flowing. Here you are having 2 ampere of current flowing. Hence, it was noticed when you keep an ammeter, 5 ampere of current was flowing. So what is this? All of you know that 5 ampere is nothing but 3 ampere plus 2 ampere. So what are they performing here? You are performing simple algebraic addition. So since you are performing simple algebraic addition, are they performing vector addition? No. You are performing simple algebraic addition. Hence, you will say current is what? A scalar quantity. Current is a scalar quantity. Is this crystal clear? Tell me. Let me go to the next part. Now, all of you learnt about vector addition. Okay. Now, there are different types of vector addition. So, still you will not be clear about what exactly vector addition is. Okay. Now, we will learn it more clearly about in this topic. Types of vector addition. So, why do we need different types? Can't we do it with single type? See, what do you know as of now? All of you know that vector addition is not simple algebraic addition. So, don't you think it is much more complex than algebraic addition? Yes, it is much more complex as compared to algebraic addition. So, you need different types to solve different types of problems. Okay, correct. Sir, can't we solve a given problem with only one method? You can do it, but it will take a lot of time. So we have two types of vector additions in your syllabus, which is triangle law and parallelogram law. And for different type of problems, you will identify which of the following I should use and solve them. So this enables you to solve the problems in a much faster manner. Okay, understood? Why do you need different types? Now, what are the two types? First thing is called as parallel triangle law of vector addition. And the second one is called as parallelogram law of vector addition. We will learn each of them in detail. Triangle law of vector addition. What is triangle law of vector addition? Now, first, let us see what does the law say. Okay, here, before going to this, remember what we are taking. We are taking vectors only. We are taking only vectors. Okay, assume you have one vector over here. What I will do, I will take and assume you have one more vector like this. Now, the resultant of these two vectors, or the result of the addition of these two vectors, is given by this red color vector. Is this clear? Okay. See, this is assume vector 1. Assume this is vector, 1 second. Assume this is vector 2. What is this red color? This red color is nothing but vector 1 plus vector 2. Okay. What is that red color? What is that red color line called? Or else you can also call it as resultant. Okay. Vector 1 plus vector 2. Addition of vectors. What did you do? You performed vector addition. Okay. You added vector 1 and vector 2. So what did you get? You got that red color line. So basically here in vectors, you need to have very good command on geometry. Okay. Then you will solve it immediately. So what is vector 1 plus vector 2 called? Vector 1 plus vector 2 gives you a resultant. Okay. Understood? Very nice. And where is the resultant? It is a red color line, which you can see. And very, very important. Just look at this. This is extremely important. See, this is tail. This is head. See, this is tail. This is head. This is tail. This is head. So two vectors to be added, they should be in what? Tail, head. Tail, head. This manner. Is this clear? Tell me. This is very, very important. Remember what I said. Direction matters. You cannot make it tail, head, head, tail. Very, very important. Yeah, it should be in alternate manner. It can be head, tail, but it cannot be tail, head, tail, or head, tail, head. Like this, it cannot be. It cannot be like this. Okay. And the result, this is what? See the resultant. Resultant will be ulta. Tail to tail, head to head. Tail to tail, head to head. Okay. I will clear all the drawings. See. Now, see this diagram for at least 1 minute and picture it in your mind. This direction of each and every vector quantity is very, very important. Now, let us go to the derivation of magnitude of resultant of triangle law. Now, in triangle law, usually we deal with perpendicular vectors, two perpendicular vectors. Okay. And if they are non-perpendicular, we will usually use parallelogram law of vectors. Okay. Next. Here. Now, let us actually derive this formula of magnitude of resultant. Assume the magnitude of this vector is A and magnitude of this vector is B. And this is what? Vector A plus B. And this is what? Perpendicular. So what is the magnitude of this? How will you find? Yes, everyone would have told it by now. It's Pythagoras theorem, which is root of A square plus B square. A and B are not vectors, they are the magnitude of those two vectors. So magnitude is nothing but root of A square plus B square. So write down magnitude, write down 90 degrees is root of a square plus b square. Clear? Simple. Now, is this always so simple? Is vector addition always so simple? It's never so simple. So that is why one more law we need, which is parallelogram law of vector addition. Okay, next. What does the law say? Now, assume you have one vector in this direction. Remember the direction of the vectors, very, very important. And you have one more vector in this direction. See, the two tails are connected. See here, the two tails are connected. This is vector 1. This is vector 2. Now, what is the name of this law? Parallelogram. Yeah. So what you will do, you will form a parallelogram with these two. Correct. Now can you see the parallelogram? Yes. Now the diagonal of that parallelogram, which is the pink color arrow, which you can see, is the resultant. Okay, is the resultant. Clear? This is the resultant. Or you can tell vector 1 plus vector 2. Okay. See, these two tiles are connected, and from this itself the vector is emerging. See, direction you see, remember, it's very, very important. Let us go to the next. So, what is the formula for this? Again, I'll bring the figure. You can see. Now, I will give the formula. Derivation, if you want, comment down below. I will do a separate video for the derivation of this. Assume the angle between the two vectors is theta. Okay. Assume this is vector A. Assume this is vector B. Okay. How do you represent the magnitude of a given vector? Like this. Magnitude of B like this. Now, the formula of magnitude of resultant. See here very, very carefully. It is nothing but mod of A square plus mod of B square plus 2, 1 second, mod of A, mod of B, cos theta. Now we will deal with some questions, okay? Quickly. Now, find the resultant of these two vectors. Okay, quickly pause the video and try it. Done. Now, this is what triangle are direct. So what is the magnitude? Should I write directly root of 3 square plus 4 square, which is root of what? 25, which is 5. So answer to the first is 5. Clear? Now, second question. Take the angle between them as 120 degrees. Okay. Find the magnitude. Nothing but what? Simple. Apply the formula. It's 1 square plus 4 square plus 2 times 1 times 4 times cos of 120, which is minus 1 by 2. So when you solve, you will get it as minus root of 13. That's it. Okay. So that's it about vector addition. So the next topic of vectors is vector multiplication, which is a very, very important topic. Okay. So that's it about in this video. If you have any doubts, let me know in the comments down below. Thank you. Bye bye.